Yes, and as a subtitle, I say it's time for Modelica to catch up with the competition regarding unit handling. And it's so good to have this talk after Hans, because there's so many things that I don't have to explain, because I knew he would talk about it first. I would say that we have generally a lack of faith in Modelica tools performing proper unit checking. And that it's therefore that you are supposed to apply the workaround to stick to unscaled SI units in your unit attributes, meaning that your units in the model, they are in a coherent system, so that when you perform arithmetic operations, there is never any hidden unit transformation factors in those operations. But unfortunately, this means that in Modelica, we don't really take advantage of units of measurements. It sort of gets reduced to a system for making sure we don't make errors in physical dimensions. Because if you're not supposed to use centimeters, if you're only supposed to use centimeters, it's almost as if you're saying, okay, my variable is a length, and everybody knows the length is in meters. So let's do a reality check. Our Modelica models are not islands. There's an outside world that we want to connect to. Quite important examples of that is that we have table data given to us on files. Maybe those measurements are not in units that are aligned with this Modelica assumption of unscaled SI. Maybe we want our Modelica model to have an imported FMU embedded. That FMU is free to use non-aligning units for its variables. We may have some external equipment that we're talking to. We are reading data from it or writing signals to it. The manufacturer is probably deciding a particular choice of unit for us. We have only to hope that it is an unscaled SI unit. We have empirical relations in literature that we want to encode as Modelica models. But what if those empirical relations were based on measurements in non-aligned units? Then we probably cannot just write down the equations in our Modelica model. As a special case of that, we might want to introduce some parameter values from the literature in the model. And chances are that those are not given in unscaled SI units. So if Modelica as a language is not taking responsibility for unit conversions, like today, what we end up is we have to externally convert our table data files. This easily becomes a mess when we get different generations of the original data with original units. We have to keep track of also the corresponding generations of the file converted to Modelica units. And by just looking at the numbers, it's very difficult to see which version is corresponding to which version of the original data. We could imagine a crazy FMU tool that takes the non-aligned FMU and wraps it in another FMU that makes it Modelica unit compatible, so that it only has unscaled SI units on its interface. We can talk to all the manufacturers of external equipment overseas, tell them to not have empirical units on their interfaces. Of course, they will happily align with what we ask them for. We can ask all the publishers to re-release all the empirical relations, this time with everything, all the measurements converted to Modelica aligned units. Of course, they will do that. When we want to add a parameter value from the literature to our model, we sacrifice the use of display unit for choosing how we want to display the parameter, because we are forced to use it for being able to set the parameter value according to the unit used in the literature. And on top of all of that, we make Modelica library implementations for all the specific unit conversions. Source unit to target unit, all of them, we make a function variant from A to B, from B to A, and we also make a block variant of that. It just doesn't scale very well with all the combination of units that you can imagine. So if we look around us today on some of these competing systems with unit handling, and I looked at Pint in Python I looked at Unitful in Julia. I looked at math.js in JavaScript. I looked at Maple. I looked at Wolfram language. All of these are relevant engineering platforms with unit support. In all of these, you can add something in centimeters to meters. And it doesn't really matter whether the result is expressed in centimeters or meters. But they do not allow adding a numeric value to a value of quantity. When I say a value of quantity, I mean a numeric value combined with a specific choice of units. In Modelica, it's all different. You can both add the numeric value 1 something in meters and just the same thing in centimeters. They're both valid, but the result is very different. This means that the numeric value, which is an example of an expression with empty unit, this expression is not self-contained because what it means as a value of quantities depends on the context. This is a big issue for Modelica. And we're kind of saved by the rule saying that you cannot add 83 centimeters to a meter, because this means that we avoid this ambiguity of what the unit of that result is, so that we don't accidentally use that ambiguously defined unit for the interpretation of this numeric value. I gotta just I'm guessing why we ended up like this in Modelica, and I think it was because unit support was not in the language from the beginning. As Hans pointed out, it was suggested by Henrik and others in 2008 at the conference. And it was done then in a way that would be a safe language enhancement. There were no changes to the syntax, only these new added attributes. And more importantly, there were no corresponding changes to the underlying numeric computations when you start using units. So you get some additional sanity checking of the units, plus the benefit of using display units. Then if we move forward in time 8 years, Francesco noted that, yeah, we have units, but checking unit consistency in Modelica is not that easy. We don't even know what the unit of a number is. We discussed this for years, but I would say that from the beginning, we were doomed to fail because there's no foundation for unit checking in Modelica. Then if we move to today, there's still no standard for what it means for a Modelica model to be unit consistent. But we do have several tools implementing unit checking. But of course, all the tools do it their own specific way. So there's no real portability of unit consistency between tools. So if you as a tool maker want to give a nice user experience for a user who may encounter models developed with other tools that those tools consider unit consistent, you cannot treat the unit inconsistencies you discover as errors by default, because there is a risk that those things you consider errors are simply passed as fine in the tool used to produce the library. And this means that by default, we have unit errors as only warnings at most in all the tools. And I think this is really slowing down the evolution of our ecosystem in the direction of full unit consistency. We also now have some tools that are providing syntax for attaching units to literals, like we see can be done in all those competing unit handling systems. And we also have a change proposal for using a constraint-based approach, this Hindley-Milner type of algorithm for unit checking in Modelica. And I'm so glad Hans spent so much time explaining what it is we are proposing, me and my co-author, Quentin, for how it could be done. And this way of doing unit checking is also the foundation on which we will describe the implicit unit conversion. So let us talk just a little bit about these unitful literals that we have seen in some tools today. A common unit error in Modelica is that you write down your equation, and because unit violations are at most warnings, you don't care about attaching the units. It doesn't make a difference to how the numbers we compute anyway, so why bother? The equation is self-contained. But of course, you're taking the sign of a time, and there's a hiding per second here that is also messing up the units of your equation. And the way you're supposed to solve that in Modelica today is that for each of these numbers, you introduce a new variable in your model. So we get all these new variables. You have to make up names for all of them. In a big model, just choosing names can be a challenge. But the new models allow you to actually provide the unit for each of those numbers. But we are, besides cluttering the model with all those new variables, it means that this equation that was actually self-contained from the beginning, now we have to go and find the definition of all these added variables to see clearly what these equations even mean. But with a syntax for expressing a literal value of quantity that is combining a numeric value with a unit, we don't have to clutter the model with new variables. And we get the self-contained equation, which is crystal clear regarding the units. And I want to give some credit to Simulation X because I think they were the first one to use this particular choice of syntax for the unit for literals. In our implementation, we have several ones you can choose from, but this is my favorite. So if we have access to unit for literals, this means that instead of just adding a number with a kind of random unit to the length, we say specifically that we want to add 0.5 meters to this length. And according to current understanding of unit checking in Modelica, this is an error if the unit of length is not equivalent to meters. Okay, that's the poor status of Modelica today. But if we can provide units for all the literals, there's no need for literals anymore taking units from the context. And it means that we can actually prevent that we have these expressions in our models that are not self-contained. And if every expression would be self-contained, it wouldn't be so harmful if you could add a meter to 83 centimeters without knowing the unit of the result. The catch, of course, is that our ecosystem is so full of these literals, numeric values that don't have units. And we really need a migration path. So before we talk about implicit unit conversion, we need to talk a little bit about explicit unit conversion. Because all the Modelica tools today, they do support display units, so they know about converting between different units. The missing feature is that this is not leveraged for use in equations. So we're proposing a syntax, and Hans had it on his slides too, some sort of syntax for converting the value of quantity x to the unit u. So our length, if we want to be able to add something in meters, if we make sure we explicitly convert the length to meters, then it will be fine to add 0.5 meters to that, even without implicit unit conversion, because we are explicitly making sure that it will work. And in System Modeler, if you want to try it, we have this packaged as a function within our System Modeler Actions package. And please feel free to see me after the talk and play around with it if you want to. Our idea for implicit unit conversion is that it should be possible to perform this addition in Modelica. But we should not break backwards compatibility, because for all the existing literals taking unit from the context, it still needs to work along our migration path. But at the same time, we have to disallow this where we have a value of quantity here that I would say is ambiguous. We can live with ambiguous units, that's fine, but it is the values of quantity that must not be ambiguous. And we do this by extending this constraint-based machinery that Hans described as the Hillner-Milner approach. But this time, instead of having constraints that express what needs to be unit equivalent, we have constraints expressing what needs to be unit conversion compatible. And after we run the machinery, we are only introducing implicit conversions if what was accepted as conversion compatible was not also unit equivalent. And this is how we make sure that in all the existing models today, where we do have that are considered free of inconsistencies according to the current proposal with Hindle-Milner, it means that we will have unit equivalence everywhere. So we will never introduce implicit unit conversion in any of the currently considered valid models. Then we build a robustness analysis graph for figuring out whether there was a problem with an implicit conversions in the end. So unit robustness is the property that we need to analyze in order to know whether implicit conversion was dangerous or not. So we build this graph on top of what we do for the constraint-based unit checking. And the places where in the graph where there's an implicit conversion, we call them a source of ambiguity because the resulting unit is ambiguous. The expressions that are without units, that would take a unit from the context, we call them sources of fragility. And those properties, they spread through your model. You can see how this is explained in the paper if you want to understand why. But we say that if a variable has an explicit unit attribute, this is robust by definition. And we don't allow ambiguity or fragility to spread across such a variable. And then if we end up with a way for robustness to reach fragility, this is when we have a problem, and we will reject those implicit unit conversions as invalid. So here's an example. It's like before, but I introduced a helper variable for the length. And this is the graph where the constraints are on the left and the variables of the unit checking problem are on the right. I use blue for origins of ambiguity. U2 is the sum unit for the sum here. So one of them was converted, one of the operands was converted to the unit of the other. And here we have the centimeter was the one that had to be converted. So there's an ambiguity of the units coming from here. And then we have the 0.5 literal here that is equivalent to the unit of this sum. So we have a fragility there. And by following these arrows backwards from fragility, we can see how the ambiguity is connected with the fragility, and we have to reject this model. And to resolve the conflict, we can add a unit to the length variable. So we don't consider the paths via the length variable. So we are effectively removing the length variable from the problem, and we can see that there's no more connection between ambiguity and fragility. And so in this case, we can allow the implicit unit conversion. So this is a very simple condition to check. To conclude, we have a world around us where we can encounter unscaled SI units in many situations. And I think Modelica as a platform needs to take responsibility for unit conversion. It cannot be up to everyone else to solve this problem. We can do it, and we can do it reliably, and that will add safety for everyone. And if we look at some of the competing technologies with unit handling, they all support unit conversions out of the box. You don't have to write your own conversion function expressing the relation between different units. They all do unit conversion without you asking for it. And they all require your values of quantity literals to express numeric value as well as the unit. Never they take a unit from context like Modelica does. We have shown that Modelica can be extended to also support implicit unit conversion, and we have shown how we can check that this is done safely so that we can reject invalid implicit unit conversion when this would be harmful. Some of the future work includes a closer look at the relation to evaluable variability. It's a technical detail. It is very fun to think about temperature units, and we have a clear idea, but I don't think our community is ready to talk about the more complicated problems with temperature units before we solve the problem with all the non-temperature units. I've also been asked several times to talk more about unit customization. So if there's time for questions, you can ask me to show a little bit more of that in a second. And I would also wish that in the future we could deprecate that a value or quantity in Modelica is expressed without a unit like this. Because if we finally got rid of that, in my robustness analysis, there would be no more sources of fragility. We could drop the entire robustness analysis. And finally, we could do implicit unit conversion in Modelica as naturally and safe as in all the other competing technologies. Thank you.